Welcome back to Data Pythons. Today's topic is about the protoplast fusion. So we all know that the plant cells it contains the cell wall, and inside the cell wall there will be protoplast. Okay. So in need to find the protoplast, first we need to remove the cell wall. So we can say the protoplast is nothing but protoplast is the cell, plant cell minus the cell wall. So first step is we need to isolate the protoplast. Okay. So the isolation step it consists of the mechanical method and the enzymatic method. So first, what is the meaning of isolation? Isolation means separation of protoplast from the plant tissues. Okay. So the process is first we need to take one plant tissues, then we need to place in the hypotonic solution, then plasmolysis occur, then the microscopic observation and the cutting of cell wall, then we'll get the protoplast. So you can see in this picture, these are the stages of the plasmolysis. So we know that the plant cell is an osmotic system, right? Plant cell, we can say it is a osmotic system, right? So the cell wall adjusts the inward pressure upon the enclosed protoplast. So the cell wall it exerts an inward pressure, okay, upon the enclosed protoplast. So likewise the protoplast will also create an equal and opposite side pressure to the cell walls. Correct? So both the pressures are then balanced, and now if the cell wall is removed, if you remove the cell wall, then the outer pressure of the protoplast will be greater, and at the same time in the absence of cell wall the expansion of the protoplast occur. Okay, so there will be expansion of the protoplast. The reason of the expansion is due to the inflow of water from the external medium. So you can see here the second stage is the shrinking of the protoplasm, and in this stage this is complete plasmolysis. Okay, isolation of the protoplasm. I need to take the small piece of plant tissue, then plasmolysis of the cells takes place. Then you can see the microscopic observation and the cutting of the cell wall by the microscopic microscalpel under the microscope, then the subsequent stages of the liberation of the protoplast and isolated protoplast and empty cell, then isolated protoplast. So if the cell wall is to be removed to isolate the protoplast, the cell or tissue must be placed in a hypotonic solution of a metabolically inert sugar such as the mannitol at high concentration. Okay. So the mannitol, we know that it is an alcoholic sugar and it easily transported across the plasmodesmata, and it provides a stable osmotic environment for the protoplast and prevents the usual expansion and the bursting of the protoplast even after the loss of the cell wall. Okay, so once the cell is stabilized in such a manner by plasmolysis, the protoplast are released from the containing cell wall either mechanically or the enzymatically. Okay, so this is the process. First, this is the small piece of plant tissue. Okay, then there will be plasmolysis, that is the shrinkage of the protoplasm when you place in the hypotonic solution. Okay. Then the C and D step is about by the microscope and need to see in the microscope. Then E and F stages with the liberation of the protoplast. Okay. Then the isolated protoplast. This is the empty cell without the protoplast, and then we can find the isolated protoplast. So what is isolated protoplast? Isolated protoplast is the protoplast which is obtained experimentally. So the protoplast obtained experimentally is called the isolated protoplast. Okay. The next step is the enzymatic method. So in the enzymatic method, most of the enzymes are similar to the plant cell wall enzymes. So mostly the cell wall enzymes, that means the cell wall degrading enzymes, that is cellulase, hemicellulase, then pectinase, right, etc. And these enzymes are isolated from in case of enzymatic method. So the entire tissue can be incubated with a pectinase which will dissolve the middle lamina. So if you will use the pectinase enzyme, pectinase, it will dissolve the middle lamina between the cells and so separate them. Subsequent treatment then with cellulase that will digest away the cellulosic layer of the cell wall. It digests the cellulosic layer of cell wall. And this process is known as the sequential enzyme treatment or the two steps treatment. Okay, here you can see. So this is a small piece of the plant tissue. First, we'll take the peptidase degrading enzyme case. So it will degrade the middle lamella between the cells and it separate them. Then we'll take the cellulase. It will dissolve the digest the cellulosic layer of the cell wall. Okay. So this is the two-step method, or you can say two enzymes are involved. Then here comes the one-step method. It's the mixed step. So in this step, it is the one step. In this step, the cellulose and the pectinase, these are the microenzymes, are mixed so that the entire wall is broken. The entire wall is broken in a single operation. So in the two-step process, first by the help of pectinase, the middle lamella dissolve between the cells. Then there will be the action of the cellulase that will degrade the cellulosic layer of the cell wall. Then only will get the entire wall which is broken. Correct. But in case of one-step method, by the mixed step, that is the pectinase and the cellulase, that will mixed and it will break the entire wall in a single operation. So then we'll get in both the case the isolated protoplast, right? So the isolated protoplast then can be cultured either in a liquid medium or in a agarified medium. Correct. And we have already discussed in the media it contains the salts like salts, vitamins, carbon source, growth hormones, coconut milk, organic acids. We have already discussed about all these things. So in the next class we are going to discuss about the protoplast fusion. So this is all about the isolation of protoplast by two methods. One is mechanical method and one is enzymatic method. So if it makes sense to you, please hit the like button, share with your friends, and do not forget to subscribe this channel. Thank you.